Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 35 video on the chapter of mensuration, where I will solve problems of chapter test number 3 on the chapter of mensuration. So this chapter consists of 10 multiple choice questions. This chapter test consists of 10 multiple choice questions, which you should ideally try to solve it in 45 minutes. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with part 35 video on the chapter of mensuration, where I will solve problems of chapter test number 3. Okay, so on the left hand side I have the chapter test number 3 problems. There are 10 questions. I hope the fonts are big enough so that you can see them properly. On the right hand side I will solve the problems. The link of the PDF of the chapter test number 3 will be there in the description below. As always, please try to solve the problems yourself, and then you can watch this video to match your answer and my approach of solving the problems. Okay, so let's start solving the problems. Question number 1, there is a figure. It says that ABCD is a square of side x units. PQ, RS are midpoints of the sides AD, AB, BC and CD respectively. A largest circle with center at O is inscribed inside quadrilateral PQRS. Okay. Then the area of the shaded region is. Okay. So we have a square. This is the square ABCD. This is the square ABCD, whose the length of each side of the square is x. Okay. Now when we join the midpoints of all the sides of a square, we also get a square. So this the quadrilateral PQRS is also a square. So this is the quadrilateral PQRS. PQRS is also a square. So when you join the midpoints of a square, the quadrilateral formed by joining the midpoints of a square is also a square. So PQ, RS, PQ, QR, RS and PS is also a square. And this square, the diagonal of this square PR, or QS will be equal to the length of the side of the square, outer square, that is ABCD. So we will have QS is equal to PR, that is the diagonal, the two diagonals of the inscribed. So PQRS is an inscribed square. So there its diagonal PQ, PR or QS will be equal to x. Okay. Now there is a circle. A largest circle is drawn or inscribed inside the square PQRS. So when we have a largest square inscribed inside a largest circle inscribed inside a square, then the diameter of this circle, so the diameter of the circle will be equal to the length of the side of the square PQRS. Okay. Now, so let's say D be the diameter of the circle which is inscribed inside the square PQRS. Remember that PQRS is a square since it's a quadrilateral formed by joining the midpoints of another square ABCD. Okay. Now first of all, let us find what is the length of each side of the square PQRS, where the diagonal of the length of the diagonal of the square PQRS is x. We know that for a square, we know if we consider, we know that for a square, the diagonal d is equal to square root of 2 multiplied by a, where a is the length of each side of a square. So the relation between the diagonal and the length of each side of a square is d is equal to square root of a, where a is the length of each side of the square and d is the diagonal. So for the square PQRS, we will have QS since the diagonal of the square PQRS is QS and PR, which is equal to x. So we must have x is equal to square root of 2 and a, where small a is the length of each side of the square PQRS. So this implies that a is equal to x by square root of 2. X by square root of 2 is the length of each side of the square PQRS. Now we have to, so what is the area of the shaded region? Area of the shaded region will be equal to the area of the square PQRS minus the area of the circle. Now next is that we have to find the radius of the circle. Now remember that the circle is the largest circle inscribed inside the square PQRS. So the diameter of the circle will be equal to the length of each side of the square PQRS. So we can say that diameter, let's say this, let's say we denote the diameter, we denote the diameter of the circle to be d dash. Let's say d dash, diameter of circle will be equal to a. A is the length of each side of the square PQRS inside which the circle is inscribed. Okay, so this implies that d dash is equal to a and a is equal to x by square root of 2. Okay, so the diameter of the circle is x by square root of 2. Now what is the area of a circle in terms of diameter? Area of the circle will be, we know that area of a circle is pi d square by 4. We know that area of a circle A is pi r square, and r is nothing but the diameter by 2. So this is equal to pi d square by 4. So the area of a circle in terms of diameter is pi d square by 4, where d is the diameter. So we can say that the area of the circle will be pi d dash square by 4. This is equal to pi, what is d dash? Pi by 4, what is d dash? D dash is x by square root of 2 and square. So this is equal to pi x square by 8. So the area of the circle is pi x square by 8. Now what is the area of the square PQRS? Area of the square PQRS is equal to a square, which is equal to x by square root of 2 square, which is equal to x square by 2. So this implies that area of shaded region is equal to area by capital AR, I mean the area of the square PQRS minus area of the circle, which is equal to area of the square PQRS is x square by 2 and the area of the circle is pi x square by 8. So if we simplify this, this will be, I can take out x square common. So this is half minus pi by 8. If I simplify this further, this will be 4 minus pi by 8. So this is equal to x square by 8 multiplied by 4 minus pi. So this is the area of the shaded region, and hence the correct choice is D. D is the correct choice. Okay, let's do problem number 2. So we have a figure. The circle with AB as a diameter. The circle with AB as diameter has a point O on AB. Okay. Two semicircles ACO and ODB are drawn with AO and OB as diameters respectively. If the ratio of the areas of the shaded region and the circle with AB as diameter is 1:m, then the ratio AO is to OB is equal to. Okay, so let's draw the diagram. So we have this big circle where AB is diameter, AB, A and B are 2 points on the circumference, so that they pass through the center. Okay, so O is a point somewhere. O is not the center. Remember, O is not the center, but O is a point on the diameter AB. And a semicircle ACO is drawn with AO as diameter. So this is the semicircle, let's say ACO. And another semicircle is drawn with OB as diameter. Let's say this be the semicircle with OB as diameter, and it is ODB. Okay, now we have so the region is shaded. It is given that the ratio of the areas of the shaded region and the circle with AB as diameter is given to be 1:m. We have to find AO is to OB. Now clearly we see that AO is the diameter of the semicircle ACO and OB is the diameter of the circle semicircle ODB. And what is the shaded region? What is the shaded region? The shaded region is area. So area, okay, let's give some name to some region. Let's say the bigger semicircle B named as the region, let's say R2. The smaller semicircle, let that region, that semicircle be R1. And we have clearly the semicircle ACO is inside the semicircle of the bigger circle with AB as diameter. So if we consider the semicircle, the lower half of the circle with AB as the semicircle, the bottom semicircle with AB as diameter, inside that we have the semicircle ACO. So the semicircle with AB, the lower semicircle with AB as diameter minus the semicircle ACO, let that region be R3. Okay, so basically the area of shaded region, we can clearly see is equal to area of R2 plus area of R3. Area of R3. Area of R3. Now let's consider area. Let's consider R3 to be the lower semicircle with AB as diameter. So the area of the shaded region will be area of R2 plus area of R3 minus, we have to subtract the area of the semicircle ACO. So area R1. So this is the area of the shaded region. We have to find this. Now clearly R2 and R1 are R2, R1 and R3. All these regions are semicircles with different diameters. Okay. Now we have to find the ratio AO is to OB. AO is to OB. Okay. So let's say let we consider AO is to OB be equal to P. That is, we are assuming AO is to OB is equal to P is to 1. P is to 1. Okay. Now also let the diameter of the big circle AB be equals to D. The diameter of the big circle, that is the diameter having the circle having the diameter AB. Let's say the length of the diameter AB be equals to D. Now, since AO is to OB, AO plus OB we can see is equal to D. And from the concept of ratio and proportion, from the fact that AO plus OB is equal to D and AO is to OB is equal to P is to 1, from the applying the concept of ratio and proportion, I can say that AO will be equal to P by 1 plus P multiplied by D, and OB will be equal to 1 by 1 plus P multiplied by D. Okay. So we have found AO and OB in terms of the given ratio, in terms of the P and D. Remember that D we have assumed to be the length of the diameter AB, and also we have assumed AO by OB is equal to P. We have to actually find the value of P. Okay. Now we have to find the area. So what the area of the big circle with AB as diameter, the ratio of the area of the circle with AB as diameter and the shaded region is given to be 1:m. So now what is the area of circle? What is the area of circle with D diameter? The big circle, what is the area of the big circle with AB as diameter? It is equal to pi d square by 4. We know that the area of a circle having D as diameter is pi d square by 4. Okay. Now we will find the area of the shaded region. For that, we need to find the area of R2, R3 and R1. So what is the area of R3? What is R3? R3 is the semicircle. R3 is a semicircle with AB as diameter. So the area, so what is the area of a semicircle? It is half the circle, half the area of the circle, and the area of the circle with AB as diameter is pi d square by 4. So the area of R3 will be half into pi d square by 4, which is pi d square by 8. This is the area of the semicircle R3. Okay. Now what is the area of R1? That is the semicircle with AO as diameter. It will be pi d square by 4, where pi, it will be pi AO square by 4, since R1 is a semicircle with AO as diameter. Okay, pi by 4. So what is AO? AO is P. AO is P by 1 plus P into D, this square. So this is equal to pi P square D square divided by 4, 1 plus P whole square. Similarly, what will be the area of the semicircle R2? It will be pi by 4 OB square. OB square. What is R2? R2 is a semicircle with OB as diameter. So its area will be pi by 4. There will be half. the area of the R1 is a semicircle. Remember that R1 is a semicircle with AO as diameter. So there will be here half. So this will be 8. This will be 8. This will be 8. Similarly, this one, the area of R2 will also be half multiplied by 5 by 4 OB square. So this is equal to pi by 8 OB square, and this is equal to pi by 8. What is OB? OB is d by 1 plus p square. So this is equal to pi d square by 8 1 plus p whole square. Okay. Now, so what is the area of the shaded region? This implies area of shaded region. Area of the shaded region was area of R2 plus area of R3 minus area of R1. So area of R2 is pi d square by 8 1 plus p whole square, and area of R3. What is R3? What is area of R3? Pi d square by 8. Pi d square by 8 minus area of R1, which is pi p square d square by 8 1 plus p square. We have to simplify this. Let's take pi d square by 8 as common factor. So we have 1 by 1 plus p whole square plus 1 minus we have p square by 1 plus 1 plus p whole square. So this is equal to pi d square by 8. Now if we simplify inside the bracket, we have 1 plus p whole square minus p square divided by 1 plus p square. Okay. This is equal to pi d square by 8, and if I expand 1 plus p whole square, I have 1 a square plus b square plus twice ab. Using that algebraic identity, I have this. So p square cancels out, and this is equal to pi d squared by 8. We have 2 plus p, 2 plus twice p, 1 plus p whole square. This is equal to pi d square by 8, 2 into 1 plus p, 1 plus p whole square. So this becomes equal to pi d square by 4 multiplied by 1 plus p. So this is the area of the shaded region. Okay. Now the ratio of the area of the shaded region and the big circle, that is a circle with AB as diameter, is given to be 1:m. So we must have pi d square by 4. This is the area of the shaded region. This divided by what was the area of the circle with AB as diameter? Pi d square by 4. Pi d square by 4. So this is equal to, is given as 1 by m. So this implies, if we simplify the left hand side, it becomes pi d square by 4 into 1 plus p, and then multiplied by 4 by pi d square. this is equal to 1 by m. So pi d square cancels out, 4 cancels out. So this implies that 1 by 1 plus p is equal to 1 by m. So this implies if I do cross multiplication, I have m is equal to 1 plus p. So this implies p is equal to m minus 1. P is equal to m minus 1. So this implies that AO by OB is equal to P is equal to m minus 1. Since we have assumed in the beginning that AO by OB is equal to P. Okay, so this implies that AO is to OB is equal to m minus 1 is to 1. So the correct choice is C. C is the correct choice. Okay, let's do the next problem. Question number 3. The dimensions of a classroom are 12 meter, 6 meter and 4 meter. That is, the length is 12 meter, breadth is 6 meter and height is 4 meter. Find the cost of decorating its walls by a wallpaper of 50 centimeter width, which costs rupees 50 per meter. So we have to decorate the 4 walls of the room by a wallpaper, and the wallpaper, the width of the wallpaper is fixed, that is 50 centimeter. So first we have to find what length of the wallpaper is required, so that the area of the wallpaper should be equal to the area of the 4 walls. Okay, so what we are given, L, the length is given to be 12 meter, breadth is given to be 6 meter, and height is given to be 4 meter. So this implies we know area of 4 walls, the formula area of 4 walls of a room is equal to 2 into length plus breadth multiplied by height. That is the perimeter multiplied by height. So this is equal to 12 plus 6 multiplied by 4. This is 36 multiplied by 4, this much meter square, which is equal to 144 meter square is the area of the 4 walls of the room. Okay. Now we have to find the cost of decorating its walls by a wallpaper. So now we have to find the length of the wallpaper, so that the area of the wallpaper, the width of the wallpaper is fixed. So we need to find what will be the length of the wallpaper, so that its area is equal to the area of the 4 walls of the room. So let x meter of wallpaper is needed to decorate the 4 walls. So this implies that the area of the wallpaper will be x multiplied by the width of the wallpaper, which is 50 centimeter. Remember, the width is given in centimeter. So this will be 50 by 100, this much meter. So this is the area of the wallpaper. So this must be equal to 144. From here we can find x. So this is x, 50 cancels 100 with 2. So x by 2 is equal to 144. So this implies x is equal to 288 meter. So 288 meter of the wallpaper is required. Okay. Now what will be the cost? The cost is given, the rate of the cost is rupees 50 per meter of the wallpaper. Okay. So this implies cost of decoration will be equal to rupees the rate, which is 50, multiplied by the length of the wallpaper that is required, which is 288. Now I will use the calculator to find the value of 50 multiplied by 288. 288 multiplied by 50 is 288 multiplied by 50 per meter. 288 multiplied by 50 is 1440. Okay, so so this is 1440, which is not matching with any of the answer. Let me see if I have done any calculation mistake. So the length is 12, breadth is 6, and height is 4. So the area of the 4 walls is 2 into length plus breadth multiplied by h. 2 into 12 plus 6, 12 plus 6 is 18. So 18 into 2 is 36, 36 into 4 is 144. Okay. Find the cost of decorating its walls by a wallpaper of 50 centimeter width. Okay, which costs rupees 50 per meter. So we have to find the length of the wallpaper that is required so that it will entirely cover all the 4 walls. That is, its area will be equal to the area of the 4 walls. So now if we consider x meter of wallpaper is required, then the area of the wallpaper will be x multiplied by 50 centimeter. Breadth is 50 centimeter. So 50 centimeter in meter is 50 by 100. So we have x by 2 is equal to 144. So this implies x is equal to 288. So 288 meter of the wallpaper is required. I don't know why my answer is not matching. Let me quickly check if I have done any wrong, if I have done any mistake in copying the question. The dimensions of a classroom. Okay. The dimensions of a classroom. Okay. So the dimensions of a classroom is 12, 6 and 4. 12, 6 and 4. And find the cost of decorating its walls by wallpaper of 50 centimeter width. Oh, sorry. I have a vision problem. So I'm sorry for that. Actually, the rate is rupees 30 per meter. Since I have a vision problem, I thought I saw 30 to be 50. Anyway, so the cost will be, so this is not 50, the rate is 30. So how much is 288? 288 multiplied by 30, it is 8640. 8640 rupees 8640 is the total cost. So the answer is choice C. Choice C is the answer. Okay, let's see the next problem. Question number 4. A wheel of radius r centimeter makes n rotations per hour. A wheel of radius r centimeter makes n rotations per hour. How much time it will take to cover a distance of d centimeter? Okay, so we know that in one rotation the distance covered by a wheel is equal to the circumference of the wheel. So circumference of the wheel is 2 pi capital R, where capital R is given to be the radius of the wheel. So this is the circumference. Okay. Now it is given that in 1 hour n rotations are made by the wheel. So okay, so distance covered, we can say distance covered in distance covered in 1 hour is equal to distance covered in n rotations, since the wheel is making n rotations per hour. So we can say distance covered in 1 hour is equal to distance covered in n rotations, which is equal to c into n, because in one rotation the distance covered is equal to the circumference of the wheel. So this will be equal to 2 pi capital R small n. Okay, so this is the distance covered in 1 hour. And the question is asking how much time it will take to cover a distance of d centimeter. Okay, so we can use unitary method. We can say that time required to cover d centimeter will be equal to, since in 1 hour distance covered is 2 pi Rn, so the time taken to cover d centimeter will be d by 2 pi Rn. This much hour is the time taken by the wheel to cover a distance of d centimeter. So d by 2 pi Rn is this much hour. So the correct choice is C. C is the correct choice. Okay, let's see question number 5. So we have a figure. ABCD is a rectangular plot of length x units and breadth y units. Okay. The shaded region is a path of uniform width of m units. So the shaded region is a path which is having a uniform width of m units. Then the perimeter of the path is. Okay. So let's quickly draw a figure. Say this is the rectangular plot, and we have, this is x, length is x units, and the breadth is y units. So the path is something like this. So this is the path. The path is having uniform width, that is this distance is equal to m, also this distance is equal to m, also this distance. So this distance, the width is m. Okay, so what is the perimeter of the path? Now let's try to visualize what will be the perimeter. Let's say, so the rectangular plot is ABCD. Let's try to give some name to the vertices of the path. Let's say this be E, and let's say this be F, G, H, I, J, and then this be K, L, M, N. Now clearly the perimeter of the path we can see is DE plus DE plus EK plus KL plus LM plus MN plus NB plus again we will have let's say J, L, M, N, let's say this point be O. Then we have DO plus Okay, so let's say this be O, this be P. So we have OP plus PF plus FG plus GH plus HI plus IJ plus JB. So this is the perimeter of the path. Okay. Now what is D? Okay. Now if you notice that if I combine DE KL, if I combine DE KL, if I add DE KL and then MN, DE KL and MN is nothing but this is equal to the length of the rectangle, which is equal to X. Okay, fine. I will do that later on. Again, if I add what is the perimeter of the path? Okay, this, and then after NB we have DO JB. Okay, plus if I now add DO plus PF plus GH plus IJ, DO plus PF plus GH plus IJ, this will be equal to the breadth of the rectangle, that is Y. Okay. Now which segments are left? I have considered DE, I have considered KL, I have considered MN, I have considered DO, I have considered PF, I have considered GH, I have considered IJ. Okay. So the ones which are left is EK plus LM, EK plus LM, EK plus LM, EK plus LM plus plus NB, EK plus LM plus NB, EK plus LM plus NB. Also notice that EK plus LM plus NB is nothing but the breadth of the rectangle. Okay. So I have considered EK, LM and NB. So the ones which are left are OP plus FG, OP plus FG plus HI plus JB. Okay. So this is equal to what is DE plus KL, DE plus KL plus MN is nothing but it is equal to the length of the rectangular plot, which is X. So this is X plus what is DO plus PF plus GH plus IJ is equal to the breadth of the rectangular plot, which is Y. Okay. And then again EK plus LM plus NB is equal to again the breadth of the rectangle, which is Y, plus what is OP plus FG plus HI and JB, it is equal to the length of the rectangular plot. This is X. The width of the OP is DO is not what is DO? DO plus PF plus GH plus IJ. So this is coming out to be 2 into X plus Y. 2 into x plus y, and I do not have any choice, 2 into x plus y. Let me clearly check if I have computed the perimeter correctly or not. So the perimeter is dE plus ek plus kl plus lm plus mn plus nb plus do plus op plus pf plus fg plus hi plus hi plus jb. And the width of the path is given to be m units, but we are not having m in the answer. Let me again quickly check if let me quickly check the problem, the reference problem. This. Oh, okay. Actually, the diagram I have drawn in this problem, this is not exactly from the problem. It is not exactly as the problem from where I was referring. Anyway, as per this diagram, as per the diagram in this problem, I think the answer should be 2 into x plus y. But where we can see that the width of the path was not it was not used in the finding the perimeter of the path. It was not used in the perimeter of the path. So the width of the path was not actually required. Anyway, if you think this is wrong, I have done something I have computed the perimeter incorrectly, then please feel free to let me know in the comment section. I will appreciate that. So all the choices are, so my answer is not matching. This answer is not there in any of the given choices. So I think I have done something wrong while giving the choices. Anyway, so my answer is 2 into x plus y. If you think my answer is incorrect and all the given 4 choices, your answer matches with one of the given choices, then please feel free to let me know in the comment section. Okay, let's solve question number 6. Question number 6 says that how many times should a wheel of radius r rotate to go around the perimeter of a square field with diagonal d? So how many times should a wheel of radius r rotate to go around the perimeter of a square with square field with diagonal d? So first of all, we have to find the perimeter of the square field with diagonal d. So we know that if there is a square, if the diagonal is d, and if all the length of each side of a square is x, we have there is a formula that relates the diagonal and the length of each side of a square. So d is equal to square root of 2 multiplied by x. So from here we will get x is equal to d by square root of 2. Okay. So we have to find the perimeter. So the perimeter of the square will be 4x. This is equal to 4 into d by square root of 2. Okay. Now this is equal to, if I want to get rid of the square root of 2 in the denominator, I can multiply both the numerator and the denominator with a square root of 2. So this becomes now 4d square root of 2 by 2, which is equal to twice of d square root of d, or this is 2 into square root of 2d. So this is the perimeter of the square. Okay, now the question is asking how many times a wheel of radius r should rotate to go around the perimeter of the square. Okay, that is, we have to find how many rotations it will be required for the wheel to cover a distance of the perimeter of the square, which is 2 into square root of 2 into d. So we know that, okay, the circumference of the wheel is 2 pi r. We know that in one rotation, distance covered by wheel is equal to the circumference, is equal to c is equal to 2 pi r in one rotation. Okay, so this implies that from the unitary method, number of rotations required to cover a distance of the perimeter of the square, which is 2 square root of 2d, will be equal to 2 into square root of 2d divided by c, which is equal to 2 square root of 2d divided by 2 pi small r. 2 cancels out. This is equal to square root of 2 d pi r. So this many number of rotations the wheel has to make, so that it will go around, it will cover the entire perimeter of the square. So the answer is B. B is the correct choice. Okay, let's do question number 7. Find the cost of fencing a plot in the shape of a sector having a central angle of 120 degree and radius r centimeter at the rate of rupees 6 per meter. So we have a sector like this. Let's say this is the sector where the central angle, that is, so the sector is having a radius r. This is r. This is r. The radius of the sector is given to be r, and this angle, the central angle, is 120 degree. Okay, so find the cost of fencing a plot in the shape of a sector. Now the fencing will be done along the perimeter of the sector. If I consider the sector to be A, B, C, then the perimeter of the sector will be equal to AB plus the arc BC plus AC. Now AB is equal to AC is equal to capital R, that is the radius of the sector. So we have twice capital R plus BC. Now what is the length of the arc BC, which is making us angle of 120 degree at the center? We know that we have a formula that the length of an arc that makes an angle of theta, the length of an arc that makes an angle theta at the center of a circle having radius small r is theta by 360 multiplied by 2 pi small r. This is the length of the arc which makes an angle theta at the center of the circle of radius small r. So in this problem, so BC will be equal to, theta is 120 degree, so 120 by 360 multiplied by 2 pi capital R. This is equal to, this will be equal to 2 pi R by 3. Okay. So, so this implies P, the perimeter, is 2 capital R plus 2 pi capital R by 3. this is equal to, if I take 2r common, I have 2r 1 plus pi by 3, pi by 3. Okay. This is equal to if I simplify 1 plus pi by 3, it will be 3 plus pi 3, and this is equal to 2 capital R by 3 multiplied by pi plus 3. So this is the total perimeter. This is the perimeter of the sector, or the perimeter of the plot, which is in the shape of a sector. Okay, now we have to find the cost. The rate of cost is rupees X per meter. Remember, the perimeter we have found is in centimeter, because the radius of the sector is capital R was given in centimeter. So this is centimeter. Okay. Now the rate is, we know that the rate of the fencing is rupees X per meter. So we know that 1 meter means cost of, we know that cost of 1 meter means 100 centimeter. Cost of 100 centimeter fencing is equal to rupees X. So I am applying unitary method. So this implies cost of 1 centimeter fencing will be equal to rupees X by 100. So this implies we have to fence the entire perimeter of the sector, and the perimeter of the sector is 2 capital R by 3 multiplied by pi plus 3. So the cost of the perimeter of the cost of fencing the perimeter of the sector will be equal to rupees X by 100 multiplied by 2R by 3 multiplied by pi plus 3. If I simplify this, this becomes Rx by 150 multiplied by pi plus 3. So Rx by 150 multiplied by pi plus 3 rupees. This is the total cost of fencing the plot, which is in the shape of a sector. So the correct choice is B. B is the correct choice. B is the correct choice. Okay, let's do question number 8. The ratio of the areas of a square and a circle having equal perimeter is, okay, so let's say this be the square of side, let's say X. No, yes, okay, so let's say the length of each side of the square be X, and we have a circle. Let's say the circle be, the radius of the circle is small r. Okay, now if the length of each side of the square is X, we know the perimeter will be 4x. Also the circumference of the circle of radius small r is 2 pi r. Now it is given that the perimeter of the circle and the square are equal. So this implies that P is equal to C, which implies 4x is equal to 2 pi r. 4x is equal to 2 pi r. Okay, fine. So this implies we can say that x by r is equal to 2 pi by 4, which is equal to pi by 2. Okay, so x by r is equal to pi by 2. Now we have to find the ratio of the areas. Okay, so the area of the square is x square, and the area, so the ratio of the areas of the square and the circle will be x square by pi r square. This is equal to, we can say, 1 by pi multiplied by x by r square. Now x by r we know is equal to pi by 2. So this is pi by 2 square. This is equal to 1 by pi multiplied by pi square by 4, and this is equal to pi by 4. Pi by 4. Pi by 4, it should be pi is to 4, and we do not have any choice. Let me quickly check if I have done any calculation mistake or not. Perimeter will be 4x. Okay. If I consider the length of each side of the square to be x, then perimeter is 4x. And if I consider the radius of the circle to be r, then the circumference is 2 pi r. So it is given that the circle and the square are having equal perimeter, which means that the perimeter of the square is equal to the circumference of the circle. So P is equal to C, which means 4x is equal to 2 pi r. This means x by r will be equal to 2 pi by 4, which is equal to pi by 2. So x by r is equal to pi by 2. Now what will be the ratio of the area of the square and circle? Area of square is x square. Okay, and the area of the circle is pi r square. So we have x square by pi r square, which is equal to 1 by pi multiplied by x by r whole square. X by r we know is pi by 2. Pi by 2. So we have pi by 2 whole square. This is equal to pi by 4. Okay. So actually the answer should be pi by 4, and it is not given in the choices. So it's my mistake. I have given the wrong choices for this problem. But I think, in my opinion, the answer should be pi is to 4. If you think I've done anything wrong in the calculation or applied the concept incorrectly, then please feel free to let me know in the comment section. Okay, let's see the question number 9. The perimeter and area of the floor of a room are P units and A square units respectively. If the height of the room is H units, then the length of the longest rod that can be kept inside the room is, okay. We know that the length of the longest rod, the formula length of longest rod that can be kept in a room is equal to square root of L square plus B square plus H square, where L is the length of the room, B is the breadth of the room, and H is the height of the room. Also we know that the perimeter, which is given perimeter of the floor of the room, P, is nothing but 2 into length plus breadth. Also area of the floor of the room is L into B. We have this. The height of the room is given to be capital H. So over here it will be capital H. We have to find this. So somehow we have to find the value of L square plus B square, where we know that 2 into L plus B is equal to capital P and LB equals to A. So we have to apply some concept of algebraic identities. Now this implies L plus B is equal to capital P by 2. Okay. Now how can we find L square plus B square from the value of L plus B and LB? We know that L plus B whole square is equal to L square plus B square plus twice LB. This implies L plus B we know is capital P by 2. So this square is equal to L square plus B square plus 2 into LB we know is capital A. We have this. So this implies the left hand side is P square by 4 is equal to L square plus B square plus twice capital A. From here we can easily find the value of L square plus B square is equal to P square by 4 minus twice A. This is equal to, if we simplify, P square minus 8A by 4. So now this becomes equal to square root of p square minus 8a by 4 plus h square. If I simplify this further, this becomes equal to p square minus 8a plus 4 capital H square divided by 4. This is equal to square root of p square minus 8 capital A plus 4 h square divided by 2. So this should be the length of the longest rod that can be kept in the room, and hence the correct choice is D. D is the correct choice. D is the correct choice. Okay, let's see the last problem, question number 10. There is a figure. So two circles with centers at P and T are drawn on a side of a square PQRS. So PQRS is a square, and on the side PS, two circles are drawn. One circle is having a center at the point at the vertex P, and the another circle is having the center. One circle is having a center at the vertex P, and the another circle is basically touching the smaller circle and touching the vertex S. Okay. So it is given that the radius of the smaller circle is 1 centimeter and the radius of the bigger circle is 2 centimeter. Then the area of the shaded region is, oh, I am sorry, I forgot to shade the region. So actually, I'm really sorry for this. So we have this square, and we have a circle. So the square is P Q R S is the square. At the vertex P there is a circle. Clearly it is in the figure, it is showing that the diameter of the circle with center at P is 2 centimeter. Okay, which means that its radius is 1 centimeter. So also there is another circle that is touching this smaller circle and also touching the vertex S, like this, and the radius of this bigger circle is 2 centimeter. So this will also be so let's say the two circles are touching at the point, let's say T, and let's say the center of the bigger circle be O. So definitely we have, okay, what is given, the area of the shaded region is. So actually the shaded region was this. This is the shaded region. So we have to find the area of this shaded region. Okay. Now things to understand is that the bigger circle is touching the vertex X S of the square, and also it is touching the smaller circle, and the smaller circle is having center at the vertex P of the square. So clearly and the radius of the smaller circle is PT, which is given to be 1 centimeter, and the radius of the bigger circle is TO, which is equal to OS, which is equal to 2 centimeter. So this implies that the length of the side of the square PS is equal to PT plus we can say PT plus TO plus TS. PT is 1, TO is 2, and TS is also 2. So this is equal to 5 centimeter. So the length of the side of the square is 5 centimeter. Now what is the area of the shaded region? The area of the shaded region is nothing but the area of the square minus the area of the semicircle having radius 2 centimeter and the area of a quarter of a circle with radius 1 centimeter. As you can see, the the smaller circle is having center at the vertex P. So we are having a quadrant of that circle which is inside the square. Okay. Now let's name the quadrant of the circle with P as center to be region R1. Region R1, and let's say the semicircle of the semicircle having radius 2 centimeter, that is inside the square, be region R2. So clearly, now first let's find what is the area. What is the area of the region R1? R1 is nothing but a quadrant. It is a quadrant of a circle having of radius 1 centimeter. So we know, its area will be 1/4. The area of a quadrant of radius r is equal to 1/4 the area of the circle of radius r. So the area of R1 will be 1/4 of the area of circle with radius 1 centimeter, that is pi 1 square, which is equal to pi by 4 centimeter square. Okay. Now what is the area of the region R2? R2 is a semicircle having radius 2 centimeter. That is the bigger circle, half of the bigger circle. It will be half. The area of a semicircle of radius r is equal to half the area of the circle of radius r. So this will be pi 2 square. This is equal to 4 pi by 2, which is equal to 2 pi centimeter square. Okay. Now the area of the square PQRS is equal to 5 square, since the length of each side of the square is 5 centimeter. This is equal to 25 centimeter square. Okay. Now, so therefore, what will be the area of the shaded region? Area of the shaded region will be equal to area of the square PQRS minus the area of the quadrant of the region R1, which is a quadrant of radius 1 centimeter, minus the area of the semicircle of radius 2 centimeter, that is the region R2. This is equal to 25 minus area of pi by 4 minus 2 pi. This is equal to 25 minus pi by 4 plus 2 pi, which is equal to 25 minus, if I simplify pi by 4 plus 2 pi, it will be 9 pi by 4. So 25 minus 9 pi by 4. If I simplify this further, this will be 100 minus 9 pi by 4. This much centimeter square will be the area of the shaded region. Hence, the correct choice is C. C is the correct choice. So with this, it brings to an end in solving the chapter test number 3. I have already solved, I have already prepared and solved 2 other test papers. Chapter test number 1 and 2 on this chapter of mensuration. If you have not watched those videos, I strongly suggest that you also watch them to have a good practice of solving good variety and difficulty and relatively harder problems on this chapter of mensuration. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So I think I have completed the chapter of mensuration. I have solved 3 chapter test problems and all the problems of the textbook of author RS Aggarwal. This should give you a good foundation of the concepts and applying them to solve problems from the chapter of mensuration. The next I will start the next chapter, which is data handling, where we will learn how to find mean, median, mode of a set of data. So please stay tuned for that video to come soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.